Hi, my name is Mamadou. This is a FSE 100 Introduction to Engineering ASU Summer 2024. Our team name, Team Ultimate, and we have a project of building 4 robots. And I am responsible for the design of the first robot, which is the voice command. And I'm going to move directly to the 3D. And this is the 3D of my robot. As you can see, front view here, you have like the 3 LED. Those 3 LED is, there are one for each robot that are going to follow. So anytime this robot send a signal to one of those robots, one of these LEDs is going to light up. And right below them, you can see the ultrasonic sensor for this robot to move, like sensing the direction of the movements. And on the at the bottom, I mean at the back of this robot, I'm going to show the back. You can see this is what you can see here is the speaker, and this robot is intended to take the dog for some command, like human phrases, like sit, come, play, to the dog. And the bottom part of this robot, you can see the wheels that can help this robot to move from one location to another location where the other robots are located. And I'm going to quickly move to the circuit, and this is the circuit here. And as you can see the Arduino, and then you can see the infrared transmitter on your left side, and you have the transmitter receiver right in the middle of the breadboard, and then you have the ultrasonic sensor and the motion sensor, and also the speaker that I have here, just in case if the dog presence is detected, is going to beep, and the red LED is going to light up. And quickly, my code here. Code is you have the setup, and then you have the setup, and then you have the loop. The loop has only two different options for detecting the dog and for sending signals. So you have two functions here: the function for detecting the dog and another function for sending signal to the different robots. And then I'm going to switch back to my presentation. So here. So just like I told you, the phrases that we have here that to teach the dog. And then after these phrases, it is going to transmit signal to the first robot, and then the second robot, and the third robot. And I'm going to let Julio keep going with the presentation.
Alrighty, guys. My name is Julio Padilla, and my job in this project was to handle the dog ball throwing robot. So I'll show you actually the 3D design real quickly here. This is basically the outside of it here. So when the signal is received by the voice command robot, this LED will emit to let the dog know that, okay, it's time to go play. On the top of this is actually a little ball catch can. So the dog will drop the tennis ball in here, or you'll have a couple tennis balls in here. And then this sensor at the top here, this little black part, is a sensor to determine if the ball is actually in here ready to be released. So if the ball is in here, it'll tell the Arduino board to start spinning up these DC motors, which are actually right here. And this will spin in opposite directions to shoot out the ball. And in here, there's also this little orange pin, and this is controlled by a servo motor. So the servo motor will rotate to pull the pin out, and the ball will drop to go through into the chute and shoot out for the dog. And I'll open this real quickly so you can see the internal components on here. These are 2 DC motors. Over here is our Arduino board. Right here is our servo motor. This is the inference sensor to receive the information from the other robot. And this is our ultrasonic sensor to determine when the ball is located in the catch can. Now, here is my circuit design. It says all the same components that I just showed you on the 3D model, with the two DC motors spinning in the opposite directions, the servo motor to release the pin, the infrared sensor to receive the information from the other robot. The LED will emit green. Then here's our power source. I'll show you real quickly that the LED does turn green, the motors spin in opposite directions, and the servo motor rotates to release the ball out. And here's my code I wrote in here. Has the setup function, our loop to determine, to let the motor spin in opposite directions on here if the ball is detected with the sensors. Now I'll go back to our presentation here. Here's the top view again. Here's the front view. Here is side view. And here's an internal view with labeling all the components. Step one is to receive the signal from the voice command robot to begin the sequence. It'll activate the red LED to tell the dog that it's time to play. The ultrasonic sensor will detect the ball. From there, the Arduino system will turn on the DC motors in opposite directions. And then it'll turn on the servo motor to rotate 90 degrees to release the ball. And then it'll continue for 5 minutes. And then it'll move on to the next section, next robot, I should say. Here is the activity diagram of how I wrote the code in the first place. And here's another breakdown of the code. And then I'll send it over to Kyle, and he was part of the dog treat dispenser robot.
Hello, my name is Kyle Skimmerhorn, and I am responsible for designing the dog treat dispenser robot. So quickly over to the 3D design. So it is designed kind of like a gumball, except for it's more weather resistant. So it has a lip on the lid for the treats to go and get dispensed into. There is a rotating turntable with a servo on the bottom with an opening right there. So as it rotates, it'll rotate 200 degrees. It'll go and go over top of the opening, and it will go and dispense the treat. It will do all this after it actually receives the command from the voice command robot designed by Mamodu. It'll then turn on the green LED to let it know that it's that the sequence has now officially started. There is the Arduino. So once it receives the signal, it'll turn on the green LED. It'll also activate the push button switch, and then at that point, it'll either the dog will push on the button or the voice command robot will tell it to go and dispense the treat. Over to the circuit. Right here is the servo. The IR receiver will go and be receiving the commands from the voice command robot along with the green LED. And the push button, it's all going to be powered by a 9-volt battery onto a small breadboard to go and help with the power load. Resistor going into the servo to go and make sure that the servo doesn't get overpowered or anything like that, along with the LED. And the IR transmitter is not needed. This is just for the simulation purposes. Back over to the presentation. So this right here is just the overall design view with the push button, the drop down tube to go and actually catch the treat. Top view should go and be able to accommodate medium and large size milk bones. There's a little catch basin down there to make sure that the treat doesn't actually just shoot down onto the floor as well. And this right here is the wire going down to the push button. But due to design purposes, it kind of had to be more rigid. So once this right here is the step sequence, so once it receives a signal from the voice command robot, it will begin the sequence. It will then activate the green LED. It will turn on the pressure button or sensor button. Then when the signal is received, it will go and activate the servo. There's also a delay function in there as well. And then that right there was just a circuit. Over to the Arduino code. This right here is just a quick little flow chart along with the code as well. And then over to Matt. with the dog back scratcher.
Thanks, Kyle. All right, I'm going to share my screen right here real quick. Take over. All right, we should be set. So I was in charge. My name is Matthew York. I was in charge of the dog back scratcher robot. Jumping into the 3D design. So here's the basic design. It's got a LED at the top. We've got the arm, control arm, and then we've got a roller right here on the back side. We've also got an adjustment screw that can go up and down for the robot. Going into the circuit, we've got the basic components. The remote is actually the voice commands robot. That's a simulation that we threw in there. It's going to send the signal over to the IR receiver, and then it activates the robot itself. So the motor is going to spin on the roller, and then the servo is going to operate the arm up and down. I can throw the code up here real quick. We've got the basic setup function, and then we've got the loop that's going to activate the motor and drive the arm up and down, and a certain number of cycles. So those cycles are depicted in the beginning, where it says how many it's going to go up and down, and that's going to determine how long the back scratcher is going to go. So into the presentation itself, we went over the basics of everything. The dog back scratcher robot is essentially the end of our entire swarm that's going to give the dog a kind of the end reward, or the calm down mode of our sequence. So there's the front view with the LED. We've got the top view, the back view with that adjustment, just to show that again. So the steps: gets a signal from the voice commands robot that begins the sequence and the loop, so that it activates the green light telling the dog that, hey, it's time to come get your dog back scratches, or your belly rubbed, so to speak. The motor begins to spin on that scratcher wheel, and the arm goes up and down. That arm is on a certain number of cycles, and then it's also it rotates up and down on a delay, so that it doesn't just go really quickly for the dog. And then the circuit, we've got our different components that we went over before in that circuit. And the code itself, there's our block code, and then we've got our actual code with everything defined on the sequence of operations. And with that, I'm going to turn things back over to Julio so that he can wrap things up on our project.
Hi, everyone. So this is real briefly our simulation of how the robots communicate with each other. The first robot will be moving 48 inches at a time. The robot 1 will motion sensor be activated. The robot 2, 3, and 4 infrared receivers are turned off. And then so the robot will communicate with the first robot, and then it will communicate with the second, and then the third, and then it'll move back to the original position. So as a quick summary on here, working on this project gave us a variety of opportunities, including being able to work as a team and make this dynamic. This is very rewarding for all of us, as a lot of us were not familiar with TinkerCAD or how to build and create circuits in the first place. So this is great learning for everyone. We also learned from brainstorming activities to writing professional texts, whether for various project deliverables to writing code for Arduino simulations. We've learned very important skills as an engineer that we'll treasure in our endeavors later on in our professional careers. And then being exposed to the basics of MATLAB, Autodesk, and TinkerCAD was a good foundation for the engineering design process that we've gained from this course. And at the end of this presentation here, we have our references of what we used as an influence to create our swarm robots. And again, thank you to our professor and all the TAs, the lecturers, for your assistance and answering questions throughout this course. This was a challenging one, and we had a lot of questions, but we appreciate every one of you. And thank you for your time today.